going to start from the beginning. Just hang tight for a minute. Today the focus is special right triangles. There's two in section 9.3. And they come from the equilateral triangle and the square. So if I look at this triangle here, it's equilateral. So looking at that triangle, the green triangle is an equilateral triangle. If you split it in half, you get this triangle here. Okay? Now I picked an equilateral triangle. Purposely I picked a 2 here because 2 is easy to work with. So if this is 2 and the triangle is equilateral, then this has to be divided into equal parts. So each one of these is 1, which is why there's a 1 there. Okay? And by Pythagorean theorem, I could tell you that h squared plus 1 squared is equal to 2 squared. So h squared plus 1 is equal to 4. So if I solve for h squared, sorry, if I solve for h squared, I have to subtract 1 from both sides. Do you see that? You guys see that over there? So that tells me h squared is equal to 3. So h itself would be the square root of 3, which is the height. But the height is also, if I take half the triangle and redraw it, this triangle has a 2 on the hypotenuse, a 3 on the long leg, and a 1 on the short leg. So I want you to memorize this triangle. And the reason is it comes up a lot, well, forever, for the rest of the time that you do math and any engineering-related, physics-related math. Anybody in here who has a parent that has done any engineering or physics, or just a lot of math, these triangles never go away, ever, 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 ever. On your standardized tests, I'm talking about the TCAP, but I'm talking about your SATs and your ACTs, all the tests you take for college, this stuff's all over it. So the sooner you learn how to use these triangles, and there's variations, but it's just going to pay off. So that triangle is kind of set in stone. So if I if I just group the little pieces here, so I'm going to get rid of the little circle there and just take the number. I want you to keep the number associated with the triangle. Okay, so you're going to keep that associated. Right? You're going to memorize this triangle. And the right angle, the square angle, remember, the longest side in a right triangle is opposite the biggest angle in any triangle. So 90 is the biggest angle, 2 is the biggest value. Root 3 is 1.7 something. Okay? So we've got this one right triangle over here, and that's one of the special triangles. It's called a 30, 60, 90. So you would have to have the values in there if it didn't, when you look over here, because we started with an equilateral triangle, the values have to be 30, 60, and 90. But once I get over here, if you see a triangle, what's going to happen is some of you guys will get really good at dealing with 30, 60, 90s, and you'll accidentally treat every triangle as a 30, 60, 90 and miss up problems. It's a really common mistake. So just because you have a right triangle doesn't mean it's a 30, 60, 90 triangle. It would have to be given that it's a 30, 60, 90 triangle. So when you memorize these values, you're going to memorize them in association with those angles. Okay? So that's one of your triangles. You're going to just have memorized in your brain forever. Okay? Then this is a square, this light turquoise shape down here. So a square, I made all the sides have 1 unit side length. So we look back over here. If all sides are 1 unit and it's a square, we have a right angle here. So when I just take half the square, it's a 1 root 2. Because it's a square, I split a right angle into equal parts. So each angle is 45 degrees. So each one of these angles is 45 degrees. And so this is your other special triangle that you want to memorize. So let's group that, and we'll just take this one over here. Okay. So those come from the regular triangle and quadrilateral, come from the square and the equilateral triangle. Does that make sense? Okay. So to do any problems with them, you have to understand similar triangles. So I'm going to add in one more page. Just to review on similar triangles from 8th grade math. In 8th grade math, you did a lot of problems that were like, maybe you'd be given a triangle and there was some shadow.
Oh yeah.
Right? And you might have had like a tree. And that tree's kind of funny looking. It's not a symmetrical tree because I can't work up the left side of the paper. And then maybe there was the sun up here, and it creates the tree shadow, which is along here. Remember these? And then, you know, so if you were, so this is like an old engineering problem. You know, you could get a decent estimate of the height of a tree. It's not going to be exact because shadows aren't fine outlines. They're not lines. But you could start here with a tape measure, you know, and then take a tape measure and just measure or count off with your feet. The old engineers did a lot, even people that do construction work or if they come in to carpet your house, most of the people that do that, they come in and they want to figure out square footage. They just walk through the house and they know about how many steps, their own feet steps, make up a yard. So a lot of the old engineers and practical engineers, construction workers, those kinds of people, they just walk off a distance. So you could get this distance, shadow length, and then you could stand either somewhere else, you would be shorter, and you could get your own shadow length. And so if you were here, there you are, standing on one foot, doing the ballet pose, your shadow could be right here. And if it's the same time of day, then your shadow and your height are going to form a proportional triangle, a triangle that's similar to the tree shadow and the tree's height. So sometimes you would see the triangle separate, sometimes you would actually see the triangle superimposed. Do you remember that? But no matter how you did it, well, you know, so there's two people, you could have a friend, right? You could, you know, you would need some help.
With tape measure.
Right? You could roll a string. Okay, so anyway, if you had like a 8-foot shadow, and maybe this was a 22-foot shadow, and you knew that you were 60 inches tall, so that's 5 feet, then you could compare similar triangles by saying H compares to 22 as 5 feet compares to 8 feet. And you would set up a ratio and proportion. H over 22 is the same as 5 over 8. Are you doing that? And the principle was that the triangles were similar because they had angle similarity. The second angle being the angle that the sun beams are projecting down. So that's why you create similar triangles. And so in 8th grade, you learned that if two triangles had two congruent angles, then the triangles were similar. So then you would multiply, and you'd say 8h is equal to 5 times 22. So solving for h, you would divide by 8. Then we could reduce a little. 2 goes into both of these, right? So we have 55 divided by 4. So 4 goes into 5 how many times? Once. What's the remainder? 4 goes into 15? 3 times. And the remainder is 3. So 13 and 3/4. What are the units?
Inches. No, feet.
Feet. That's an old similar triangle problem. You guys remember that? Okay. So new similar triangles, similar triangles are proportional. So as long as you have 2 equal angles, then, well, you automatically have 3, then you have similar triangles. So if we look at this page here, and I'm asking you to use similar triangles, and the only thing, let's ignore this one for a minute. I'm just going to shrink it up for a minute. We'll get to this one. Hey. Okay, so we'll look at that in a minute. If this is the problem here, you have a blank page, and the question is use similar triangles to find all the missing sides. You're not going to see this triangle. This triangle is in your brain. Nobody's going to give it to you anymore. So, like, you're supposed to look at this problem and all by yourself create this triangle. Because it's memorized. So, unlike last year, where they gave you 2 triangles to work with, in this case, they're going to give you 1 triangle, but because this 1 triangle is a 30, 60, 90, you're going to think of this triangle. Okay, so question, or you have a, okay, so what would you do?
So, they're similar triangles, so the 3-to-1 ratio is the same as y to 2 times x to the square root of 3.
Yeah, so it would help some people if this triangle was like oriented the same way, right? So like even though this is in your brain, it would be nicer if it were like flipped, right? Like you kind of want to think, because the board is not that smart. So it doesn't flip for me. So basically what's going on is you're going to do what Josh is going to do. You're drawing in your brain, you're going to draw, maybe the first time you're going to say, well, I know the one that came from that equilateral triangle had a hypotenuse of 2. So the shortest side was 1, and the third side was the square root of 3. So you're going to, like, think of this triangle here. You have to come up with it because you have it memorized. And then, now set up a ratio, Josh. So he's going to do these compared to these 2. Do you see them? So you could start with 2 at a time. So he's doing the top triangle to the bottom triangle, short leg to short leg. So short leg, or bottom triangle to top triangle, and then long leg to long leg.
But you didn't flip those.
Did I flip? Oh, I did flip them around. Thank you. It's hard for me to talk, write, and listen at the same time. I think it's out of my skill set. Okay, 1 to 3, root 3 to y. You see the mistake I made?
Actually, Josh made it, I remember.
Okay, well, we fixed it. That's what's important. Jacob.
Are we gonna have to go like that in depth with all the writing on the 2 capital C sample?
No, so we're going to do shortcuts in a minute. And some of you are going to use shortcuts forever, and some of you are never going to use them. Some of you are going to draw the little picture every time because you're visual. And those of you that are not as visual will do shortcuts. So we're not done yet. So we have to solve for this. So we know y times 1 is y, so it's equal to 3 root 3. That's the first part. You get that? Okay, Connor.
Well, yeah, if you multiply it by 3, or if you actually do multiple, here's how
Yeah, we're not there yet, but we will be. Okay, so that's okay. Raise your hand if you understand how we got y.
Wait, you have to do the last side too.
Right, so I haven't gotten x. So Natalie, if I want to get x, I've got to compare x to what?
3 root 3 over
So x compares to
2.
2. So we have to pick another value. How about 3 to 1? So I'm using 3 to 1 because it's easier than using the ones with square roots. Does that make sense?
Yeah.
So then I just cross multiply, and I get x is equal to 6. Okay? You get that? So if I add a page in here, because there was another problem that I squeezed to tininess, let's bring it back. Okay, so who can do this one? Okay, Luke.
Okay, so what I did is I said that the square root of 3 was equal to 2.
So you're comparing, because the square root of 3 is not equal to 2. It's being compared to 2, because it's the hypotenuse of a 30, 60, 90. And so what would you have here? That's the beginning. What would you have down here?
Like,
What value on this triangle?
oh, 1.
1. And what value would be here? Root 3. So this is always tricky, because people feel like the square root of 3 can't be anywhere else. But you can make the hypotenuse any length you want. So now we're going to compare the square root of 3, right, to 2, like Luke said. So root 3 compares to 2 as, you have to go this,
Yeah, z compares to
z compares to the square root of 3. That's the first equation. And so cross multiply, the square root of 3 times the square root of 3 is 3. 3 is equal to 2z. So divide by 2. And you get z equals 1.5. Do you get that? So that's one of the values. Now for the second value, for w, what are you going to do?
Wait, yeah, I do. Square root of 3 is compared to 2, and then w is compared to 1.
Yeah, square root of 3 still compares to 2, as w compares to 1. So cross multiply and you get 2w equals the square root of 3.
So it's square root of 3 over 2.
So it's the square root of 3 over 2.
I got that, but I forget how I did it.
Well, you did it twice. Okay. Okay.
I'll remember.
That's okay. So we're going to talk about patterns here.
Yeah, Connor's got it.
You can.
I got it down. Do we need to have the correct? We need to do correct in order to realize.
Yeah, let's save a little bit of class time for that. Okay. So I'm going to talk about some shortcuts. We haven't even talked about the 45-45 triangle yet. So let's, hey, that one didn't get all grouped together. While I'm grouping this, why don't I need the 45-degree angle in this triangle? Yeah, Jacob?
Because you have the isosceles markings.
Right, because it's isosceles and right, that's another way to show both angles would be 45. So, what were you talking about, Jacob? You had a question about patterns, right? Like,
Oh yeah, I was saying, do we have to like go through all the work on our page, or can we just, you know, if we see one ratio, can we just do it on our head?
if you can see the shortcut, by all means use it. But sometimes it's really easy. Guys in the back, I need you to stop for a minute so I don't have to, it's hard for me to talk and hear you guys. If it's obvious, right, and this is a 6, and that's a 60 and a 90 and a 30, you should be able to find x and y.
X is 3, Y is 3.
Okay, so some people are gonna find it real quick, x is 3, that's correct, because maybe what you need to do is visualize, some of you, obviously not everybody does, that this was part of an equilateral triangle. So this is 6, so that must be 3. And then eventually, the long way would do Pythagorean theorem, and if you did Pythagorean theorem, you'd get 3 root 3. But since this is tripled, then this would have to be tripled, which is why we get the 3.
Yeah, that's
So you don't need Pythagorean theorem anymore, because you should know the property of the triangle. So if I triple the hypotenuse, then I tripled everything. Does that make sense? But sometimes it's a little harder to see. So if I said this is 30, and this is 90, and that's 60, and this is a half, then what is Z, Connor? And what is W?
0.25 and then 0.25 times square root of 3.
Okay, so what did you do?
Just divide it. I divide the half by half, and then I know that the height is always the base times square root.
So if we take this triangle, even though you're not necessarily going to draw it all the time, he noticed that in this top triangle, he's looking at the relationship from here to here is always dividing by 2. Right? To get from the hypotenuse to the shortest side, he's just cutting it in half. So he's not actually using similar triangles anymore. He's just using the relationship of this triangle related to itself. That's how a lot of people do that. Other people may set up similar triangles, but it comes from the property of similar triangles. But if you understand, you just have to divide by 2. Half of a half is a fourth. It's a great shortcut. You see that? And to get from here to here, we just are timesing. We're multiplying by the square root of 3. Think about it. Over here, we actually multiply this way by 3 to get this, but if you look at the relationship from the short side to the long side, it's the short side 3 times the square root of 3. So that would make W 1/4 times the square root of 3, and the way you would write that would just be square roots of 3 over 4. So anytime there's a 30, 60, 90. I'm going to say this though. I'm going to give you a quiz next week, and only some of the triangles are going to be 30, 60, 90s. And what happens is people start making everything a 30, 60, 90.
Are the other ones going to be on that?
Well, I might give you, right, just 3, what about, don't forget you had a 3, 4, 5 triangle. So here's what happens. Sometimes, and I'm only telling you this because it's so frustrating for everybody when you learn something really well that you forget to pay attention. Like, if I said this was 3, and this was 4, that's a 3, 4, 5 triangle. That has nothing to do with the 30, 60, 90 triangle. In fact, it's not a 30, 60, 90 triangle because 5, when you divide 5 by 2, you don't get 3. So what I'm saying is that eventually they get mixed up on a page, and when we start mixing them up, you have to really pay attention to whether or not you have the 30, 60, 90 triangle. And that's something for another day, but it's just something to think about. I'm going to pause for a minute.
Wait, can I?
I'm not quite to the formula for the 45, 45, 90, but I will be. So,
Curious what I missed here.
yeah, you didn't miss it. So, okay. Just one more practice. If we do one more triangle, and I say it's a 30, 60, 90, and it's not so easy, like what if I say this is the square root of, 6, and this is 60, and this is 30. Somebody new. Find the other sides, X and Y. Okay, somebody new. Raise your hand.
X would be square root of 6 over 2.
Okay, this would just be square root of 6 over 2. And then what would y be? Let Alexis do it.
Square root of 9? No, 3. No.
What do you do to get from here? Here you divide by 2, right? What do you do down here? It's getting bigger, right?
Minus 5.
So you times it by the square root of 3. So square root of 6 over 2 times the square root of 3.
So it would be the square root of 18 over 2.
It would be, and that simplifies though, doesn't it? Because 18 is 9 times 2.
So it would be 3 times the square root of 2 over 2.
Yes. That's your final answer. Okay? So what if we put one more in here and you start with something else? Like maybe you start with the square root of, no, not the square root of a billion. What if, what if you change this up a little bit and you take the same number, which you put it here, and this is 60 and 30. We're going backwards. Yeah, you're dividing by root 3, right?
So that's square root.
Yes, that's the square root of 2, and then you're multiplying by 2, so that's 2 root 2.
Why do we divide by root 3?
Because we're going from the longer side to the shorter side.
Yeah, wouldn't it be square root of 2 times square root of 2 is 4?
2 times the square root of 2,
Oh.
not the So when it gets a little weird looking, that could be the time that you bring in the triangle you know for sure to cross-check your work. That's when the similar triangles maybe could be handy, right? Some people may want to use the similar triangles all the time, but if you get a little uncomfortable and you're not sure, then just check it. You would say, suppose we didn't know this and we're going to just call it X. We didn't know this, we're going to call it Y. So you could just say, well, I know root 3, it's definitely more work, compares to root 6, as 2 compares to X. And you could just check your work. You could just check it. But really, at your level, you guys are so good at patterns that this is sometimes a lot of work for something you can do with a pattern. But when I do that, I have to go back to some algebra and remember that I could do square root like this, if they're square roots. And so this does end up being 2 square roots of 2, but it was a whole bunch of work to get that answer if you understand the pattern. Does that make sense? Okay, Jacob.
Couldn't you just say that since you're multiplying the hypotenuse by root 2, you could check your other work for multiplying by root 2?
Sure. In fact, that's what I'm hoping you're going to do. But I'm saying if you are not to where you see the patterns going this way and coming this way, you could always go back to similar triangles and set up a relationship. It's just an option. You have 2 ways to do the problem. Your choice. Okay? So those are the harder ones. The 45, 45, 90, that's actually so much easier. So if I take this problem here, this one, let's cut it and put it on a new page. So it's so much easier to do any one of these. If I have a triangle here, and I say this is like, we'll start easy. If this is 6, this is 6 root 2. Does everybody see that? As long as it's marked as a 45, 45, 90. Because to get from here to here, you're multiplying by the square root of 2. But if you don't see that, you could just treat it as a variable. It's half of a square, right? So I put my X in the wrong place. So maybe that's too fast for some of you, which is normal because not everybody thinks the same way. If if you do this with 6, well, it's half of the square, that's 6. So you could always just say 6 squared plus 6 squared is equal to x squared. And so you don't really need to memorize this one nearly as much. So this is 72, right? But that's the same as 2 times 36. So 6, 6. So there's your pair. So it's 6 root 2, but that's a lot of work. That's a 2. If you know the pattern, it's really handy. Yeah, you just multiply by the square root of 2. To go from the leg to the hypotenuse, you just multiply by the square root of 2. How about to go from the hypotenuse to the leg? Divide by the square root of 2. That one's easier. So, of course, that's the easiest one. So if I had a triangle that was a 45, 45, 90, that doesn't really look like one, but we'll use our imagination. I'm telling you it is. And I said this was 8. What's x? Yes. You have to divide 8 by the square root of 2. So now you guys that are working ahead, you have to remember how to rationalize, so I would stop here. So 8 divided by the square root of 2 is not considered a final form. So it's not considered simplified. So you need to rationalize it. You learned this last year. You don't usually, and I say usually because sometimes in calculus you do, you don't usually want a square root on the bottom. So you multiply by this value, which is just 1. And you end up getting 8 root 2 in the top over 2, which is the same as 4 square roots of 2. So x is 4 square roots of 2.
Wait, so what you can basically do is like take away the square root sign and like put it up to the top and then just divide it by the number.
It's just.
Yes, that's it. Okay, I'm going to stop this. That's really long to record for people, but the kids that were going, I told them I would do this. I want to pass back your tests and let you look at them, and we'll talk about that. Your homework tonight is section 9.3. So 9.3 is on the sideboard, but it was supposed to be yesterday's homework. 477 it starts on. 477. And problems 1 to 18, 22 and 23. So